All right, so today we're going to be talking about completing the square when you've got variables as the coefficients. And we're going to start with a leading coefficient of 1. So let's say that we've got x squared plus px equals q. Just like we've been doing all along, we're going to start by drawing a rectangle to represent that, where we've got x as the length of one side and x plus p as the length of the other. So the total area is x squared plus px, which is equal to q. Now we're going to cut that px chunk in half and move half of it down to the other side so that we now have that lovely L shape with two sides the same length, x plus p over 2. And then we're going to complete the square by filling in the missing piece. The area of the missing piece is p squared over 4, because p over 2 squared is p over 2 times p over 2, which is p squared over 4. That then allows us to set up the equation x plus p over 2 squared equals p squared over 4 plus q. So that's the area of the box equals the area that we just added plus the area we started with originally. On the right-hand side there, we've got a fraction that we would like to be able to add to q. So we're going to make a common denominator, rewrite the right-hand side as p squared over 4 plus 4q over 4. And then that's going to get us x plus p over 2 squared equals p squared plus 4q all over 4. Move that to the top of the board since we're running low on space. At that point, we can take the square root, remembering to have the plus or minus. So we now have x plus p over 2 equals plus or minus the square root of p squared plus 4q all over 4. And when we've got a fraction in a square root, we can split it up to have the square root in the numerator and the denominator separately. So now we have x plus p over 2 equals plus or minus the square root of p squared plus 4q over the square root of 4. Now the numerator, remember, we're not going to be able to simplify because we have addition in that square root. So if we've got addition or subtraction, we cannot simplify without factoring, and there's nothing there that we can factor. The denominator, on the other hand, we can take the square root of 4. So that's going to get us x plus p over 2 equals plus or minus the square root of p squared plus 4q over 2 now. And the goal is to get x alone, so we're going to subtract p over 2 from both sides. That gets us x equals negative p over 2 plus or minus the square root of p squared plus 4q over 2. Now we've got two fractions with the same denominator. We can combine them into one fraction, so we have x equals negative p plus or minus the square root of p squared plus 4q, and all of that is over 2. And that's our final answer here. Because there's nothing else that we can simplify, we've got x alone on the left-hand side, no x's on the right-hand side, and so this can be used as a general formula anytime that you have a quadratic equation in the form x squared plus px equals q. The solution is x equals negative p plus or minus the square root of p squared plus 4q over 2. Ta-da!